Okay, this is going to be a quick video on inverses of logs. Okay? Now these aren't wicked nice, but they're not wicked bad. We'll just do kind of a basic one here. What if we said f of x or y is equal to log base 3 of x plus 2 minus 4? Okay? Now to begin, I'm just going to graph it out roughly, and I think there are other videos on this, but we'll get the idea real quick. What if I have 3 to blah, blah, blah? So let's say if I want the result to be 1. 1's a nice one, right? Well, if I want it to be 1, x would have to be negative 1. Well, if x is negative 1, I get 3 to what power is 1? Well, that would be 0, right? And 0 minus 4 is negative 4. What if I want it to be 3? Well, if I want it to be 3, x must be 1, right? Well, 3 to what power is 3? Well, that'd be a result of 1. And 1 minus 4 is negative 3. And so forth and so on. And what if I wanted this to be 9? Well, if this is 9, x must be 7. Well, if x is 7, that's 9. 3 to what power is 9? That'd be 2. And 2 minus 4 is negative 2. Done. So let's see, I get a few basic points right here. Dun, 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 dun. Okay, now remember my domain, we want to say x plus 2 is greater than 0, x is greater than negative 2, not including that point, so I'm just going to put a vertical dash line. That'll be a vertical asymptote of that function. So let's see, negative 1, negative 4. So if I do negative 1, negative 4, there's a point. If I do 1, negative 3, there's a point. If I do 7, negative 2, blah, 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 and what I get is something approaching that. And that's a graph of that log function. Okay. Now, what if I say I want the inverse of this function? Well, I already know it's going to be an exponential because, I mean, that we knew that. Let's see what we can do here. Okay, first thing, why don't we flip our x and y? We've done that in many different times before, right? So let's say we have x equals log base 3 of y plus 2 minus 4. Let's say I want to solve for y because I want a new function, correct? Well, I'm going to add 4 to both sides. What if I have x plus 4 equals log base 3 of y plus 2? Okay? So basically now what I'm saying is 3 to this power. Well, 3 to the x plus 4 power is equal to y plus 2. And notice I lost my log right there when I get to that point. Now I'm at a minus 2. So basically what I'm saying again is y equals 3 to the x plus 4 minus 2. Here we go. That's an exponential function. Now if I can bear with me for a second here. What if we say x is negative 4? Let's think of nice numbers that make this work out. Well, if x is negative 4, I get 0. 3 to the 0 power is 1, and 1 minus 2 is negative 1. Okay? Now, if you're looking, you're like, hey, wait a second. Did they just flip the domain? Yeah. Isn't that what an inverse is? Let's try another one, though. Why don't we try negative 3 just to prove the point? Well, if that's negative 3, 4 take away 3 is 1. 3 to the 1 is 3. 3 minus 2 is 1. Done. And let's just do what we're doing. What if we get negative 2? Well, if that's negative 2, that's 2. 3 squared is 9. Now minus 2 is 7. And look what we have here. So if I do negative 4, negative 1, 1, 2, 3, 4, negative 1, and I do negative 3, 1, and I do, where am I? Negative 2, 7. Yeah, it's just kind of what I thought, right? If I throw in a y equals x identity function, we just sketched the inverse of a logarithm, which is in that form of an exponential, and we're good to go. Okay? Now, what if I said, well, basically, what if I'm looking here, and I said, well, I want to get this back in inverse form, find the inverse of that exponential. Well, let's think for a second. Why don't we say x is equal to 3 to the y plus 4 minus 2. I'm going to add 2 over. X plus 2 equals 3 to the y plus 4. Well, it looks like we're going to say 3 to this power is this result. So I know we're going to have a logarithm here. I know it's going to be base 3. I know if it's 3 to this power, it's going to be y plus 4. Is this result? It's going to be x plus 2. And then I minus 4 and minus 4. And I think we're back to the original. Okay? So that wasn't that bad. Let's just do one more quick inverse. Now what if I throw in a y equals ln of x plus 3? Now, this is a little bit trickier. I'm not going to graph this one right now, but I do want to find the algebraic inverse. Now, you think you've done a lot of things with ln and e, but right now what you want to remember basically is ln is really defined as log base e. Okay? Well, if ln is really log base e, we're kind of in good shape, right? So y equals log base e of x plus 3. Well, if we do this math out correctly, could we say e to the y power is equal to x plus 3? Well, if e to the y power is equal to x plus 3, and I flip my x and my y, now I'm going to say e to the x minus 3 is equal to y. And if I can say that, well, that's pretty much what I'm saying. That would be an exponential. Remember, base e would be like an exponential. And this and this are inverses. Okay? I think that's all you need from me right now. So we learned how to graph a logarithm, or practice that. We learned how to find the inverse, vice versa, and the inverse even of, there we go. Okay, good.